In this video, we'll continue our discussion of exponential growth and decline. To start off, we're going to think about how the number 100 grows and declines. We'll start by multiplying 100 by 1, and that'll give us 100. So multiplying by 1 keeps our number the same. There's no growth or decline. However, if we multiply 100 by 2, we get 200. So this would be growth. We started with 100, and multiplying by 2 turned it into 200. Similarly, if we multiplied 100 by 3, we would get 300. So this would be another example of growth. We started with 100, and multiplying by 3 gave us 300. Now what happens if we go the opposite direction? Let's say we multiply 100 by 0.90, so a number less than 1. If you multiply a decimal by 100, you can get the answer by moving the decimal 2 spots. So we would get 90. So we started with 100, and multiplying by 0.90 turned it into 90. So this would be decline. Our 100 became 90. And we'll continue to see decline if we multiply by another number less than 1. So let's say we multiply by 0.5. 0.5 times 100, moving the decimal 2 spots, gives us 50. So our 100 became 50. So the pattern we've seen is that multiplying by 1 does nothing. Our 100 stays the same. However, multiplying by numbers greater than 1 leads to growth. And multiplying by numbers less than 1 gives us decline. Now let's write these numbers in purple a different way. So we're going to rewrite those purple numbers as 1 plus something. So if we start with our first line, 100 times 3 is the same as 100 times 1 plus 2, because 1 plus 2 gives us 3. So we're just rewriting this in a different format. Similarly, the next line, 100 times 2 is the same as 100 times 1 plus 1. In our next line, our purple 1 becomes 1 plus 0. Our next line, 0.90 becomes 1 plus negative 0.1. And then 0.5 becomes 1 plus negative 0.5. Our numbers in parentheses here are the same as the numbers here, but now we can interpret them differently. Using the distributive property, we can see that each line turns into 100 plus something else. In every line, we're starting with 100 times 1, and then we're adding 100 times something else. So writing it like this helps us think about the growth a little bit better. We're always starting with 100, and then we're going to add some piece that makes that 100 grow or decline. If we have 0 here, we don't grow or decline, because 100 times 0 is 0. However, if the number is bigger than 0, then we are growing. And if we add a number less than 0, then using the distributive property, we're going to add a negative number there, which means our 100 becomes smaller. So if we summarize this, if we have 100 and we multiply it by 1 plus some number in pink, if our number in pink is greater than 0, we grow. As we saw above, when our pink number was 0, there was no change, we stayed at 100. However, when our number was bigger than 0, we got growth. And we also saw that if our number in pink was less than 0, we decline. That's what we saw with these numbers. When our pink number is less than 0, our number in the end is smaller than 100. So our pink box is important. It determines how much we grow or decline. We used the number 100 in this example, but we could have put any number there. Because of the distributive property, we're always going to start with that number, and then our pink box is going to make us add or subtract something. If we add, we grow. If we subtract, we decline. Let's try to bring this into the real world. Let's say 100 represented how many followers we had on Instagram. If we had 100 followers and multiplied that by 3, we would have 300 followers. And you could say, my followers tripled. Now what happens if we write our 3 using our 1 plus pink number? We would have 100 followers times 1 plus 2. Overall, we're still multiplying 100 times 3, but this format can give us a different interpretation. So we still have 300 followers in the end. But since we have that too, we can say my followers increased by 200%. Both of our interpretations are correct, but they just give a different perspective. And let's have a brief review of percents in case that 200% is confusing. Let's say you wanted to find 50% of 100. You would turn 50% into a decimal and multiply that by 100. Multiplying any decimal by 100 moves the decimal point 2 spots, and we get 50. So 50%, or half, of 100 is 50. Fair enough. What about 75% of 100? 75% becomes 0.75, and multiplying it by 100 moves the decimal 2 spots and gives us 75. Now what is 100% of 100? Well, if you have 100% of something, you have all of it. So 100% of 100 is 100. And if we write that as a decimal, 100% becomes 1.00, and multiplying that by 100 moves the decimal 2 spots and gives us 100. So 100% of 100 is 100. Now let's say we want to find 150% of 100. So 150% is just 100% plus 50 more. So 100% is 100. 50 more would give us 50. So 150% is 150. And if we show our work, 150% we would write as 1.5, and multiplying that by 100 gives us 150. And if we wanted 200% of 100, that's saying we want 100% of 100 and then another 100%. So 100% of 100 is 100, and another 100 gives us 200. And showing our work, 200% we write as 2.00, and then multiplying that by 100 gives us 200. So every number that we multiply by 100, we can represent as a decimal or a percent. So if our pink number is 2, because of the distributive property, we're going to have 2 times 100, which is the same as 200% of 100. So we start with 100 followers and then add 200% of that. So we can say my followers increased by 200%. Understanding these percents and decimals is important, so feel free to rewind this section. And before we continue, there's a little bit of vocab here. Our purple number here is called a growth factor. A factor is something you multiply, just like with factoring polynomials. So whatever this number is here determines whether our starting number grows or declines. So we call it a growth factor. And when we rewrite it as 1 plus a pink number, we give that pink number a special name. We call it the growth rate. So you might remember the word rate from distance rate time problems. It's going to mean the same thing here, which is speed. Our pink number is going to determine how fast we grow or decline. That'll make a little more sense in our next example. And when we write the 2 as a percentage, we call it the growth percentage. Or more commonly, you'll hear percentage of growth. These are important terms to know, especially when you get to word problems. They'll often say something about the growth rate or the growth factor, and you need to know what those words mean. But for now, let's return to our example, about 100 followers, and add one more piece to it. Now we're going to think about our 100 followers growing over time. So let's say we start the year with our 100 followers. And by the end of the first year, we've tripled our followers. That means we'd multiply this number by 3. 100 followers times 3 would give us 300. And this would give us the number of followers we have at the end of year 1. 100 times 3 would give us 300. Now let's say that by the end of year 2, we've tripled our followers again. That means we would multiply our 300 here by 3. And multiplying that across would give us 900. So at the end of year 2, we have 900 followers. And let's say we continue to triple every year for 5 years. So if we multiply by 3 again, that's the number of followers at the end of year 3. Doing it again gives us the number of followers at the end of year 4. And one more time gives us the total followers at the end of year 5. And if we multiply these numbers, we're going to get some end amount. The actual amount isn't important right now. What we're trying to focus on is that we're growing by a certain rate every year. Now let's try to clean this up. So we have 100 followers. Now we're multiplying 3 5 times. So how can we rewrite that? We can use exponents. So this would be 3 to the 5th power. And multiplying this would still give us our end amount. Now let's rewrite our 3 as 1 plus the pink number. So we'd have 100 followers times 1 plus 2, all of that to the 5th power, and this would still equal our end amount. Now I mentioned before that this pink number is our growth rate, and now we can see that it determines how fast we're growing. So whatever that pink number is determines how much our followers grow every year. And that 2 is saying that we're growing by 200% every year. So we're starting with 100 followers and increasing by 200%, and then increasing that by 200%, and that continues for 5 years. If that pink number were bigger, let's say 6, that means we're growing by 600% every year. So if we started with 100 followers, increasing by 600% would get us to 700 followers at the end of the first year. That's a lot bigger than the 300 followers we had up here. So our growth rate determines how fast or slow we're growing over time. And that phrase, over time, is important here. The only reason we have time is because of that exponent. That exponent's telling us we're increasing by 200% every year for 5 years. And if we change that exponent to a bigger or smaller number, it'll give us a different end amount, because we'd be growing for a different amount of time. Our example here used followers. But in general, if we have some starting amount and we multiply it by 1 plus a growth rate, and we multiply by this number in parentheses for some number of years, we'll get some end amount. And as we mentioned before, our number in parentheses is called the growth factor. That growth factor would be our number 3 above. So this equation that we have here, we call this the exponential growth model. And as we saw before, if our pink number, our growth rate, is greater than 0, we grow. In other words, we have exponential growth. And our x-axis shows us the number of years that we're growing. And our y-axis would give us the end amount. And on the other hand, if our growth rate were less than 0, we would have exponential decline. This exponential growth model shows up quite a bit in the real world. We can use it to model the growth of a population. We can use it to model the growth of money in a bank account. We can even use it to model how fast a contagious disease spreads through a population. In that case, our end amount would be the number of people who get infected.